Hi, I'm an old guy and I do maths, and this is one of the videos that I've made because it was suggested to me by a student who asked me about this question. So let's have a look at it. We are to find the gradient of the tangent function y equals tan theta where theta equals 0 or pi on 4 and pi on 4. Now what we know is that dy d theta in this case is going to equal sec squared theta because we're dealing with a tangent. And I'm going to spoil the surprise and tell you the answer to the first one anyway. If theta equals 0, y equals 0, and dy d theta equals 1. And this is what had my student completely perplexed, because she put 0 here and for her trouble got 0. And that's not how this one works. This is how it works. It works using a trig identity. We know from one of the many trig identities out there that 1 plus tan squared theta is equal to sec squared theta. So if we place a value in here, such as 0, we're going to get whatever this equals. Simple as that. 1 plus tan squared theta equals sec squared theta. So 1 plus tan squared theta equals sec squared 0 in this case. 1 plus 0 equals sec squared 0. Sec squared in this case equals 1. The gradient is 1 for that reason. Try it on a calculator, check it. You'll find that the gradient of the tangent at that point is 1. Now, the second part of this is done slightly differently. So let's have a look at that. Now, remember, we were looking for the gradient of this function, y equals tan theta, where theta equals pi on 4. Now, the tangent of pi on 4 is 1. 1 over 1. There we are. Now, we also know that the secant, which is part of the derivative of a tangent, is the hypotenuse over the adjacent. So the secant of pi on 4, which is the value that we're looking for, is going to be root 2 over 1. Now, what this means is that sec pi on 4 is equal to the square root of 2. So, sec squared theta, where theta is pi on 4, is going to equal the square root of 2 squared, which equals 2. And that is how you get your answer. Don't get turned off by this. You might not feel like doing derivatives of tangents every day, but they're just derivatives. It's not a big deal. I do hope you found this useful. It took a little bit of explaining, but I think it's worth getting your head around. And as I say, if you found it useful, please like and subscribe. I'll see you next time. Bye.